Our knowledge of the laws of nature are not perfect. They're models that do the best job of representing the universe that we observe. The intent of science is to model. The intent of science is to always improve. If we find something that doesn't match observations, then we have to go back to the drawing board. The universe as code is what we believe is a possible way to describe our universe. It's a description, it's a model, but it's something that we feel maybe we can reduce that. Maybe we can come up with an analog in code to demonstrate the viability of our theory that if we could reduce and represent the laws of the universe as code, right now they're physics equations that have error bars and everything's fuzzy, but that's the way the universe is. We think we can take the universe that's written in science and turn it into Python or whatever. On a very, very small, very, very simplified scale, just to demonstrate that what we're thinking about has some feasibility. The point of this would be that we look at whether the universe could be represented as code, even on a very, very small scale, and get an idea of what the computational requirements would be for doing so. Now, if we live in a simulation, do we care? Well, we're scientists, of course. We want to nitpick and come up with theories. But I think that more fundamentally, our thought was, if this were the case, and just on the wild assumption that maybe the universe is a simulation, it is code, it is running, and it is, it has been successful, but there are rules that are followed, and that's the same way that computing works. That's the same way that coding works. So we want to figure out what could we do to represent that, because if we can represent the universe as code, then we can figure out there must be vulnerabilities, there must be gaps, there must be exploits. And if we can exploit the universe, we can hack it, we can perhaps we can travel across the universe and do amazing things that we can't do today with our knowledge of how the universe works. So I'm going to pass this off to Parker. We want to give a little introduction where we were last year, and Walter's going to introduce a little bit about what we're thinking this year. But the panel is going to be looking at the whole nature of reality, and we forgot to do our mushrooms in advance. I'm sorry. But we're happy to, over the open bar tonight at the Bill Murray after party, happy to discuss this further. So I'll give this to Parker.
Guaranteed water. Okay, this works. Great. So last year, just as an overview, and we sent the slides out if you guys want to review that, we started out with, let's make an attempt to model a universe. So in honor of the people who like flatness, we started with a 2D universe where instead of inverse square laws, it's just over R. Realized 3D is a little different, or it's not that much harder, so we ended up doing that. And one of the methods we're going through this is why it's not a simulation, why it totally is, oh wait, why it's not. And so what we did is we showed that to parallelize everything, if each point in space is its own processor, maybe that's a way that's more computationally efficient, which really uses a relativistic universe because everything's going at the same speed, even though we're going to argue about variable speed of light, and I'm a variable speed of light guy. But then the other piece too is we realized if you have field strength encoded between each point, you can have a probabilistic model. Does this particle move? So we did that with electricity. We got magnetism because relativity gives us magnetism, kind of, which we're going to get to in a second because other weird quantum things happen. So later on we were talking just because we knew we were going to be giving this talk and realized, okay, how do we actually do strong interaction? Because we didn't do that last time. So as more discussions over bourbon and cigars, we realized, well, you could do colors attract. However, if color charges were random, so with strong force colors attract if they're different, repel if they're not, protons would blow themselves up. So can't really work, so you have to have these weighted averages. We have these groups of 3 charges, we have the 3 gauge bosons. So is there a weighted average function? So like that could create something similar to get all the forces to unify. However, then I sat down with Walter, knowing what he would say, and gave me a lot of reasons of why that is completely wrong, which goes to our theorists versus experimentalists. And so I'm going to give this to Walter.
Oh yes, didn't decades, but I grew up as an experimental physicist, which means it was my job to keep the theorists from having too many crack dreams. So I love models. I like to break them. And that's actually...
I love models.
I do, I love models.
They're super.
And the way that we go through models, should I use the alarm clock?
Yes, I like that one.
So you had this old brass and glass alarm clock, you know, the old times with the bells on top, and you gave that to a group of people and said, go ahead, you can't open it, but go ahead and make a copy. And nowadays the kids, they get some stepper motors, put a chip in it, put some speaker in it to have it tick and things like that, and you'd have it all up there and it's perfect. It's moving like a clock, it's ticking like a clock, and then the original rings. It's like, okay, so now you take it all apart and you put more motors in, more timers, and now the bells ring and everything works just fine. And if you opened the original clock, you'd find springs and gears, and you'd like, well, so don't confuse your model with reality. The other part about models, though, is we look for ways to turn left. So trying to use a computational model instead of a traditional physics model, that's exactly the path we want to do till we can find one that works better. Astronomy is my example there. Ptolemaic astronomy, thousands of years ago in Egypt. Earth was in the middle, everything moved in perfect circles. Looks great. Well, it's not perfect. So put a few extra circles in it. Now there's epicycles. You could drive that model till it is perfect, and they could predict solar eclipses and everything you want. And somebody comes along, a guy named Copernicus, and goes, sun's in the middle. Oh, that makes it so much easier. And then things are still in circles, and it's still not quite right, and you're playing with it. Another guy comes along and says, Kepler, he says, oh, it's not circles, it's ellipses. And all of a sudden, that works better.
Well, he was very upset that it was ellipses.
Oh, yeah.
He was a very religious man and wanted a perfect universe.
He did.
And realized our universe was not perfect.
And we get too attached to our models sometimes, that's for sure, and that's where I come in as the experimentalist. It's great. Model's good enough to get things done, but we always look for ways to break it. In high energy physics and the things you were talking about, you can't mess with it too badly because you've already proven certain things are testably true. So my universe is something that is testably true, something that is testably false, and everything else. They live in the everything else. I will never say, if I can't test it to be false, it's not false. If I can't test it to be true, it's not true. And if my test evolves and tells me that my first test was wrong, then I have to rebuild that again.
Well, what's interesting is in our conversation, I'd almost forgotten because it's getting it so attached to this model, like you were saying. It's like, wait, we could almost get some things right and kind of wipe the board clean and start over. But very quickly you said, well, you forgot that weak interaction and electricity are actually the same force, and they become totally the same thing when you get to really, really high energies. And I'm thinking, okay, well, I kind of like my model, but then you're able to say, no, but we've actually seen this with our equipment. We know this for a fact. I'm like, oh, crap. Okay, so now it's an interesting model, not to be confused with reality. So interesting for mathematicians, which we can learn from different universes and studying them, but not any closer to creating a model of our universe, which we're kind of a little bit more interested in.
So we're talking here at a high level about modeling and representing the universe as code. And one of the caveats is our understanding of reality is going to be limited by our evolution. As humans, the human mind is not perfect. It's biased. It's evolved over millions of years so that we can survive. And so there may be certain things about the universe that we can't understand. Relativity is something that dogs just don't understand. We love dogs, but they just will never understand relativity. And so looking at the nature of reality, we wanted to expand our thoughts And so I'd like to hear from Winn about where he thinks the universe resides.
Well, I'm glad you asked that question, John. Thank you. If we're in a simulation, is there a creator? Is it a god? Is it a teenager?
Is that relevant, whether they call themselves a god? They're a being that was...
Not at all, because I'm looking exclusively for a moment at capabilities of what capability an orchestrator, a creator, the game manager of our existence, what would that being have to be able to do? One, they'd have to be able to do atomic level engineering at a minimum, perhaps quark level engineering, and perhaps even some sort of control over pieces of the quantum realm in order to build what we've got around us. They would need to be able to have remote manipulation to influence we as carbon units, but would also have to be able to, through atomic engineering, modify and control our environment that we perceive as an objective reality, just as they would be able to modify us. They should be able to influence our minds, put memories into us, remove memories, affect our perception of time through chronoception manipulation. And what dimension would this other controlling capability come from? So out of all of the capabilities I just described, what does that sound like to you that has nothing to do with reality? These are the capabilities that are necessary if we are to believe any of the UAP phenomena that we are observing. These are the capabilities. And I find it interesting that the capabilities alleged to go with UAP phenomena are exceedingly similar and map very neatly into those that would be needed for a being to be able to control or build or manage this universe in this way we perceive reality.
All right. My observation, something that I had an aha moment when he was saying that, when we talk about, we have UAPs, UFOs, little green men, but the economic cost, not money, but just effort, time, energy to travel across the universe, to travel across the galaxy. I have no doubt in this huge galaxy, this huge universe, that there are other life forms out there. In fact, I would posit that that we are not special, and that we are an outcome of the algorithms designed by the creator. And so if this game creator has engineers that go into the game to adjust and fix and monitor things, I think that could be another cause for the UAPs.
And it really doesn't matter because we don't know enough.
Oh, yeah.
All we can do with UAP phenomena is look at 70 years of subjective perceptions and look at what the necessary capabilities from an engineering and science standpoint are necessary in order to justify any of those capabilities.
Right.
Greg, what do you have to say about this?
Well, thank you for getting down here to the end. I don't know why I'm here. I'm an epidemiologist. I study diseases.
Vice President said the same thing.
Yeah, I'm not, no. I think you all bring out some very interesting points here. I'd like to just talk for a minute about injecting into the game itself, because we look at that as some external to internal input, but we're to the point now where we're actually having internal input into our game. We're having researchers actually put memories in your brain, that something you didn't do before, but now you have a memory of it. Several research projects going on like this that are altering your ability to know who you are. Part of it came out of a very positive, noble cause, I guess you could say, and helping people deal with traumatic experiences. But they've taken it to another step now, and it's actually being used to create substantial memories for people of things that they've never had. And this also leads to ethical issues, I think, in this scenario. But back to Winn's point, if we don't know enough to know who's manipulating the game that we're in the first place, how do we know it's not the person sitting next to us who's actually a controller who's been put in place?
That's my point. Are we NPCs in the game?
NPCs. Is anyone 42?
So interestingly, with humans, I was thinking kind of with Winn's point and with Greg's point, if you're simulating a universe, it would almost be harder to interact with the humans, like at least from the way we've been doing it, and we're bacteria versus humans, like the people who would be doing this know a lot more than us, and I think the only way to actually have enough computing power is to increase the speed of light, which kind of goes to the first point. If you're simulating at the subatomic level, you might not even, the carbon-based molecules might be just a consequence of that, which is really funny because this model, this software is more likely to become self-aware because it did, we are aware, versus a large language model that has no idea what it's typing. So it's almost, this is the self-aware, just a bunch of random particles. But
So at the subatomic level, right, you don't have that feedback into a cognitive sensor. So your brain is not actually, you're not aware of what's happening at that subatomic level. You'll receive the feedback.
Everything's following rules.
I think GPU, not CPU. When every point in space is parallelized, because I think that's the only way to do that, you have to interact with so many different processors for each molecule in the brain. It's almost because if you're coding a universe, you want to focus on maybe like a proton to start out with, and then maybe get up to the hydrogen atom, because I don't think we've ever solved anything bigger than the hydrogen atom with our quantum models at all. I haven't even gone past hydrogen.
No, we haven't gotten it. I just made me think something very interesting, which is, it's a very big universe and we're a very small part of it. Maybe we're just a bug.
Well, that's true, and I don't think that I think part of the simplification is, it depends. We don't know the mindset of the super being that is outside of our universe in whatever dimension that is, right?
Well, it doesn't have to be a super being.
Well,
no,
it doesn't. It could be a lab.
It could
be a lab tech.
Any other intelligence. It doesn't have to be greater than ours. It could be orthogonal to us.
It doesn't have to be other intelligence. It could be us, ourselves, that are managing and controlling in a different dimension. That's something that we seem to exclude every single time, that we are actually functioning as the controllers of the game ourselves, unaware at our three-dimensional level.
Well, I think it's kind of interesting because if you went to, there's a depth in physics that we are starting to try to figure out, which is really hard, because let's say we have a theory of everything. Is physics done? I don't think so, because there's the next question. Why are our constants what they are? What makes them what they are? Why does 1 over the square root of 137 show up everywhere? But if you are making UAPs, you can manipulate that. Simulation or not, if you understand why are those constants, you could speed up the speed of light or change its direction and have a zero-G force vehicle that can move everywhere.
And I think in coming up with this model, we don't have perfect knowledge. We don't know what happened to create our universe. We don't know the boundary conditions and the initial conditions. And so, what we have is our approximation through our human brain of observing the universe.
I got nothing on that.
And that's okay, because, the approximation of what we perceive, right, it is tremendously limited by our ability and our understanding of our environment and who we think we are in the first place. And that could be perceived perception of who we are.
If you look at, take the Webb telescope or the Hubble telescope, and they show you a picture of Betelgeuse, or however it's pronounced and it is really pretty blues, and then they take a picture and tomorrow it's red, and the next day it's yellow. It's because there's different filters being used in order to examine it. Now, keep in mind that the human, we can only sense, I believe it's 0.00035% of the electromagnetic spectrum up to 1 terahertz, if I'm correct, something like that, which means that probably for the sake of our survival, the vast majority of reality we don't even begin to perceive. So it makes a lot of these questions a lot harder. And then when we're looking at alleged behavior that is seemingly impossible, given our knowledge of existing physics today, that certainly suggests that there's something more behind the curtain. But how are we going to find it and test it? Sir, how are we going to do that?
We keep growing. I mean, before this century, we didn't know about neutrinos. And when we figured out neutrinos, we stepped back. And if you looked at the universe with that knowledge, you would see a sea of photons and a sea of neutrinos, about 50-50. And there'd be some tiny, tiny impurities. That would be galaxies and us. And now we're thinking dark matter the same way in dark energy. And we finally start to see gravitational waves. So we are digging in and trying to look wider and wider, but every time we find something new, it was totally invisible and unexpected.
And you mentioned gravitational waves, so it's not just the electromagnetic spectrum that we can observe with, right? They're all of the strong, weak, electromagnetic, and gravitational influences are observable if we have the technology and the knowledge, which we don't at this point. So we learned how to detect neutrinos. And I will say Geordi's visor on Star Trek would just tick me off, because you know how much it takes a light year of lead, I think it is, in order to stop a neutrino 100%. Because it's so tiny, it's so light, and it doesn't interact with other particles.
We need to fix that.
We really need a particle accelerator in a close orbit of a black hole. I think that's like when you talk about some things, that's what
I think that's exactly where our budget should go to.
Are you telling me I should go build a black hole in my backyard? I'll work on that.
That sounds awesome. I'll join in on that.
Well, the other thing that we went with brain, reality, perception, and this is, again, right at the edge of where people are thinking, is how much of the neuronal processes in the brain have quantum components that's all the only, that's as far as we've gotten.
Yeah.
We haven't gotten any further than that hesitant question because the implications, if we can start doing any sort of measurement or quantum level squid-like super quantum interference device used from the military in the 80s so they could do weapon systems with their brain. And if that is, and that was not quantum, that was actually EEGs. But if we have quantum stuff going on here, that is potentially a major game changer from an awareness standpoint if these guys can figure out how to measure it.
Yeah, that's true. The brain, we don't understand what consciousness really is. There's a lot that we don't understand. We still don't know what the whole bottom of the ocean is like. We've seen more of Mars than we have the depths of the ocean.
James Cameron up here. He'll tell
I called James Cameron and he wasn't available, so I got Greg. I think I'd like to, anybody have a comment they really want to make, a burning issue? I would like to go to the audience. Greg.
One comment real quick. So the panel of what we're exploring right now, it reinforces the fact that we're talking about our perception of where we're at. Because 50 years ago, this panel would have a completely or moderately different perception of what we thought we understood at that point. 600 years ago, we were talking about Galileo and Copernicus, and their perception of what they believed and what they saw and what they thought was the truth is completely different in many ways from where we are right now.
And Einstein might have a more influence because it's still about frame of reference. Perception is frame of reference based upon the filters around us and within us. So
Thank you for finishing my thought.
Yeah.
All right.
And one other
Walter?
thing I'll add to that is that our natural physics, I've been teaching physics for many years, and if you go into a high school or something and start teaching physics, there's something you need to understand. Your brain has a physics built into it. It's how you cross streets without being killed and catch balls. The physics is Aristotelian. It's wrong. It is not natural to think
Well,
this way.
we-
This is very
you know,
engineered thoughts.
I just developed this activity for the kids program. It kind of explaining a little bit about how the brain works and how it evolved to be a pattern recognizing machine and how we're good at recognizing faces and things like that because of evolution. And you know, in our survival, right? That was the important thing. And so it wasn't as much the accuracy, it was I don't want to die. Yeah. And so, you know, it could be, you know, tomorrow, it could be 1,000,000 years from now, and it may not be humanity, it might be our robot overlords, but we don't know where in the future, if at all, we will ever gain. I don't believe we'll ever have a full knowledge because we don't have access to full knowledge about everything in the universe. We only see our little bit.
Until you can define full knowledge, you can't have it. It's like artificial intelligence. How do we have it if we can't define intelligence? We don't know what it is.
Well, and I think that just a final comment, I want to go to the audience and see if we have some questions, that what we do observe is that this intelligence seems to arise from complexity. And the more complex our systems of systems are, the more there's that opportunity for a spark that becomes what we might call intelligence, but we don't really understand.
But it also brings to question, what does artificial mean? What's the definition of artificial?
Well, yeah, these are all human concepts. We've come up with these concepts because we need concepts and models, and we want to objectify the universe. We want to say, oh, that's a person. Well, that's a person with arms and legs and bones and skin and, you know, an ugly bag of mostly water, whatever the reference is. And we take this complex system and our brain reduces it down.
So 3 weeks ago, in a laboratory, a human embryo was created. And it was created from complete synthetic material. Amino acids and everything were built right in the lab.
Was it human DNA?
It was, they made human DNA, is what they had done. So now there's a 14-day rule and a 28-day rule for embryo research for cutoffs, and you have to discontinue the research after those days for ethical and moral reasons. But if that embryo was allowed to mature, is that a person?
It's another definition.
That is completely synthetic. You can't sit there and say, that's a person. I don't know.
You also
and
can't say
you can get to the
sure.
point of, if you want to go at the theologian aspect, does that synthetic person have original sin?
Well, and again, there's a lot of human history that gets us to thinking dogmatically. And that's another difficulty that we have to overcome. But I'm wondering, can I get an upgrade for my 3D printer to start printing DNA?
So, actually, that was one of the thoughts I had when I first saw this, was can I start printing DNA at home? And what can I make from that? Because I can certainly, my plants, to be honest, my plants could certainly use an upgrade. They're brown, they're ugly, and my dog is fine, but the plants really need help.
We don't even understand how, you know, we have computer vision, and it's been kind of a neural networks and training, and it works. You know, that's how it works. But as humans, we don't understand. It doesn't think like us. It doesn't work like our eyes and our nerves and our brain in interpreting what we see in our limited amount of the universe and the electromagnetic spectrum.
Greg, go ahead. Greg, I got a question for you because we're talking about this, and you're an epidemiologist, and so obviously people are going to say with printing DNA, and you could do some absolutely horrific things, So how can we use this tech to fix some of the horrific things if someone does that?
So that's a great question, but that goes back to the human condition, I would say, of the moralistic society that you are trying to operate in, or a moralistic society, what the rules are for that society. And again, those are all imposed by society itself, right, on what's going to be acceptable, what's not acceptable. In China, they made 42 embryos, and they tested to see if they could eradicate beta thalassemia, which is a very deadly disease in some of the bad cases. And 41 of those embryos died almost immediately. The 42nd one was supposed to be terminated at 28 days, so it doesn't actually grow brainstem and things like that. And on day 35, the Chinese had not terminated. So it depends upon who is doing what with technology.
Well, and you're talking about humans.
Right.
And we're not alone in the universe.
Audience questions?
So, because one of the thoughts too is if someone's making a disease or other DNA molecules that can do horrible things, would we be able to possibly use the same tech to stop diseases that are synthetically made? The same way?
So there are several ways to stop diseases from spreading. One is to understand what you made in the first place, I guess. So there's certain aspects of diseases that are actually made that we don't study, and they're made for purposes to say, okay, we want to study at a deeper level what's happening and I'll take the du jour, the coronavirus aspect, right? I'm not saying that this is made in the lab or anything like that, but to understand how other coronaviruses work, there's 4 human coronaviruses that are very benign. You get the common cold from it. Everybody, has experienced that. But there's 3 that are extremely deadly, and they all started after we started doing gain-of-function testing. So you have to, put those pieces of the puzzle together. To address your question, at the DNA level, the CRISPR-Cas9 capability now of DNA editing, or for all you computer people, cutting and pasting, okay, nucleic acids into a strand of RNA is what you're doing with that. That's what the Chinese had done to try to get rid of the beta thalassemia in the embryos. So yes, there is a great opportunity to mitigate and actually eradicate different diseases. A good one would be polio.
A comment you mentioned, the morals and ethics and values of different societies and communities and individuals. And now we're designing tools that are, I don't want to say thinking for us, but computational tools like AI that are out there trying different combinations, whether it's genetic, right? And in any case, they don't have a moral compass. I mean, other than any guardrails that are programmed into them. So I don't see this slowing down.
One of you talk about the pathways through the universe. One of the issues of making a huge ass glitch in the matrix is called nuclear weapons. And when you take, 10 to the 15th joules down amount of power at the microscopic level, originally Oppenheimer and those guys said, maybe it'll set the whole planet on fire. Or maybe it'll rip a hole in space-time, and then 31 days later, after the Trinity event, was a alleged landing from somebody who noticed our warp signature drive.
Well, maybe, but the issue before we go to the audience is what a lot of people don't understand is just how big the sun is. And those nuclear bombs, it's dwarfed that. It's made a nuke look like what makes a 22 look big in comparison to what we're trying to compare it to. But it's kind of interesting. What is kind of interesting thought is in the helium nucleus, think 2 protons. You know how much force there is? And it's a really small thing, like smaller than you can ever fathom, like makes atoms look big. That's 20 pounds of force in there. And what's kind of crazy is when Einstein first thought nuclear weapons wouldn't be possible, It was because we didn't know the neutron existed. And that's what we were doing back then. We didn't even know the neutron existed.
Well, if you go down to the Planck level, 10 to the minus 35 meters, and you had 20 pounds, you had a big bowling ball, and you squeezed it down to the smallest unit of space that we feel exists, because anything smaller would, create a black hole and destroy itself. That is what we feel was the energy equivalent, compressing that down to that size, of the creation of the entire universe.
That's what you need to do to study
And is
quantum
the
gravity.
universe reacting to our new...
But I don't know if we're off topic.
I would be terribly surprised if it did. As I said, it's a very, 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 very small thing. Somebody else might react. The universe doesn't care.
All right.
It's never worth an argument later.
We've wandered around, had a wonderful conversation. Does anyone have an observation before I go to the audience?
Go to the audience.
All right. I'm curious. What are you thinking? Have we raised any flags or your interest in anything in particular? Is there anyone who'd like at this point? Otherwise, we'll keep going. That's no problem. We can do our 50 minutes. We have a question over here.
A few?
I'll come down with the mic.
Yeah. Hi, guys. First question I have is, what evidence suggests that a mind is required in order to actualize our data set that we're talking about?
What?
I couldn't hear you.
What implies, or what evidence implies that there is a mind required to actualize the initial data set?
I'm not sure.
If the universe is a simulation.
Either way.
But yeah, well, and we're not. That's not part of our theory. It's whatever it is.
Okay.
Yeah.
So it's
It doesn't have to be a super being. It doesn't have to be an intelligence. It could be, hey, the universe is just this thing that goes on and keeps creating, bubble universes, and it's just, and there is no.
Infinity
I know.
messes with our
We
minds
can't-
beyond belief.
Right, we
Because
can't-
As soon as you said one, then it's how many infinities, and Feynman and all those guys had to figure that out.
Right. I mean, yeah, the universe again could be beyond our comprehension and so large and just never had a start. I mean, and we don't understand time, right? We don't understand time.
We don't understand time. So, in large measure, I think you even said this at the beginning, which is, from a practical point of view, it's kind of irrelevant. It's like, I just want my steak and to be a rock star, like they said in The Matrix. The question is, can we test any of it? And that's really hard when you're inside the bubble.
That's true. We don't have. You're inside the experiment, right? So we don't have the ability to observe. Although, if it's a simulation, then there's a simulation above us and another, or below us. What is the base reality, right?
The layers are extremely interesting.
It's turtles all the way down.
Well, the other thing, too, is it could be...
You just mentioned, I'm sorry, you just mentioned that we don't understand time, but John just said we can talk for 50 minutes. So we
have a model that kind of explains times at a human level.
Right. So at that level, we do understand, right, the constraint and framework and things like that, which we had to create for ourselves to deal with not understanding what the true nature of time is.
Yeah, we have the conundrum that time seems to flow in a direction. There's an arrow of time, and entropy increases. But all the equations that we use in physics can go both ways. Time could be one way or the other, and we feel that, based on our understanding, that before the Big Bang, time didn't even exist. So I don't know what does that mean, right? So I think that our understanding of time is relative. But speaking of relativity, we don't understand what it's like to be an atom. We don't have an inert feeling because we didn't evolve as quantum mechanic sized beings. We're not the size of an atom or a nucleus or an electron. And at the same time, we don't know what it's like to be really massive, like a galaxy or a black hole. We don't know what, and compact like a black hole. We don't know what it is to travel near the speed of light, right? And so we have human limitations. I guess that's my point, as far as our understanding. Yeah, we really didn't have mushrooms.
One thing we could do is thinking about what the experiment of is simulation or not a simulation is you have to start with the models, but one way to maybe disprove that, similar to the whole thing of intelligent design, is are there things that would have made the intelligent designer really stupid? So if there's some way where this model shows that it is mathematically impossible for it to not be the most computationally efficient system, you could say there's a lot of different things where if there was a creator who could have optimized that, they would have. Why wouldn't they have done that? And then you got to have a lot of experiments to test this model to do that, to have somewhat of an argument.
Or you have just purely the anthropic principle, and that's an easy throwaway.
Strong and weak anthropic principle that the universe exists because it exists, and if the laws weren't the way they were, we wouldn't be here. So
I don't know.
And then you're starting to get into epistemological solipsism. It's like, I don't even sure you're here. I'm the only one who stays all the time.
yeah, I started with the concept of Plato's cave last year.
Yes.
Are we a Boltzmann brain? Is it going to end?
But regardless, I mean, our initial thesis was very basic compared to the journey we've been on this afternoon. Are there any other questions or comments people would like to make? All right, David's coming up, and then let Abby have the mic.
Would there be any way that we, from within the simulation, could detect if the time of the simulation had been paused, rewinded, or even fast-forwarded in some manner?
You have the other microphone. You can give that to her. One of the interesting things is if you, and this is funny. They just did Are We in a Simulation? I think 2 weeks ago on Futurama, the new Futurama season on Hulu. I'm not pitching them, but it's a fun show. And so they had the whole thing. And in order to not overtax or overclock the CPU, and whatever, you have to watch the episode. I don't want to give away spoilers, but they slowed the clock speed down, and so time was passing. It appears normal when you're in the simulation, but perhaps millions of years equate to an hour, right? So it doesn't have, the time in the different simulations don't also have to correlate.
Well, I'm thinking too, one interesting point is we could have a simulation where if they did slow down, pause, fast forward, if the whole thing is deterministic, then if it's calculated, yes, you could completely have that be indistinguishable, would never know. And that went to one of our thoughts where a lot of people say, well, we can disprove the simulation hypothesis because you'd need to build a computer as big as the universe. But the counter to that is, well, what if you build a simulation where 1 trillion years is the time it takes to simulate a second? We wouldn't know. And there's a lot of things in reality that are indistinguishable. So even back to physics, dark energy could be the speed of light slowing down. It is indistinguishable to us. So the way time moves, we probably wouldn't even know. Wouldn't even know. They could pause it, start it back up. Could have happened already.
I'm going to address can we see the glitches in the matrix? And this is, I'm speculative, and it's part of my fun in the evenings.
I think we're all speculative.
There are a lot of cool YouTube videos of glitches in the matrix that are basically super anomalous kinds of things that were caught on film. And you can put on your conspiracy hat, or you can take ayahuasca and come up with a different answer. but the potentials for glitches in the matrix it certainly exists. It's like the guy who's wearing modern clothing that shows up in a Victorian photo from an early daguerreotype. And with today, but that's also before today's fake everything.
Yeah.
I want to let Abby ask her question because we're short on time.
Okay, so it seems like a lot of what you were saying, especially towards the beginning with the whole, is there a thing that has created all of this? It's kind of equating to what seems like, what if it's not like some huge, amazing, something happened to create this? What if it's just, how I kind of related to it in my head was, what if we're just kind of a save file in someone's game when they're playing The Sims and they just happen to be good at modding? What if we're just some form of something in a giant different series of simulations? What if what if we're just a miniature bit and a part of it, there's the theory of parallel universes and such. What if we're just a tiny piece in a much larger amount of simulation?
Right, and from our perspective, we don't recognize that we're just a tiny piece in this. I have to refer you, I think, to the philosopher Rick and Morty, and when they went to Blip and Shits and were playing the game where they lived out an entire lifetime. So, or the Star Trek episode. I like to have media, movie and TV analogies.
Yeah, we can't even figure out our bubble.
So think if it's The Sims, the human attention span is small enough that we'd be a lot smaller. I think there'd be a lot fewer people if it was The Sims. So it might not be exactly The Sims.
But if you look at the size of the universe and you go down to Planck's distance, our human size is roughly in the middle.
Yes. Well, compared to the size of the universe.
Yeah, when you scale it each way. And there's another little piece of data that in itself is meaningless, but boy, it made me think. There are roughly, John, correct me, 10 to the 80th hydrogen atoms in the universe. Every single one is identical.
Every proton is identical. So the configuration of the protons and neutrons and electrons.
And then imperfection evolved out of that. Deal with that, experimentalists. Figure it out.
All right, we have a couple minutes. I can give you a couple minutes because I own the show. If there are any closing comments anybody would like to make.
I'm going to give you all this mic.
I think this has been an interesting, but again, very speculative. And I think we're going out there and trying to think about these ideas and push the boundaries. But maybe there is a way that we can start to model that and see, is this something that's even feasible? Could the universe be something that is, we're not trying to guess if there were to be, a scientist who created this universe. And what they think and what their universe is like, because that's unknowable. We can't know what's outside of the universe.
We are Roblox.
But if we are in that situation, and to Greg's point, we probably wouldn't even know that we are NPCs in a cosmic game. So
all we are is we're existing in VMware. VMware is our God for what we need to understand who we are and where we're at. So I don't need a scalable size of the universe to do a study about the universe itself. I just need VMware.
Or to direct deploy to bare metal. Sorry.
But you need a wormhole to be able to get from one
all right, and
to the next V.
well, Walter's going to have a black hole in his yard, so you can have the white hole.
We'll be there.
No, the yard black hole might not be good enough for that experiment because we might need to be near a supermassive to really be in a strong gravitational field, which is pretty far away.
I'll try to make a big one.
Well,
all right, I'll see you in the next life, the next universe then.
Wait, I thought it was, it's not called Next Life. What's the game? Second Life. We have infinite life. Yeah, there are some concepts that mankind may just never know. I think we've covered a lot in this almost hour, and I really appreciate all of you coming and listening. Thank you, and let's thank the panel. We will. If there are any other questions, we're happy to take them. But all right, thank you.
That was good.
Back to the awareness of constraints.